This is the third video that shows the research results of our work at integrating agent-based modeling with traditional evaluation tools at multiple times over the course of an evaluation. In the previous video, we focused on the history of our work, its intellectual foundations, and where we are now. In this video, we get into details of what happened when we applied our process to evaluation data for the Arizona General Education curriculum. Thanks to the Faster Forward Fund for supporting this project. If you have questions these videos have not answered, feel free to get in touch with any of us. As we began work, we confronted a foundational question. What were we evaluating? The answer was that we were evaluating the effect of having AJAC certification on progress through a 4-year college. We had no data on students' activities while they were at community colleges. We only knew whether they had AJAC certification or not when they transitioned from a community college to a 4-year university. Developing that model proved to be an intensive intellectual activity that required much consultation within our group and discussions with AJAC personnel. The challenge was to come up with a model that met 2 criteria. It had to be a reasonable depiction of the program, and it also had to be true to the data we had in hand. Meeting both of these criteria proved to be tricky. The problem was that the data we had were not enough to describe the logic of the program. That meant that we had to add elements on which we had no empirical data and to rely on random picks from a data range as the model ran. We faced some hard choices. The more elements we added, the greater the likelihood of departing from hard empirical data. The fewer we added, the less the model would depict an accurate logic of the program. There's no good answer to this conundrum. The best we could do was to rely on our individual expertise and the wisdom of our group process. By the way, problems like this are inescapable in all evaluation scenarios. Any model can be over or under specified. It's impossible to know what the right level of detail is, although having a great deal of empirical data can help. Every box and arrow is a hypothesis that could be wrong. Once we had a firm idea of what we were evaluating, we proceeded along 2 tracks. One track was to work with the data to get familiar with the database structure, field definitions, and so on. The second task was to develop a model. Here is the model we developed. In the pictures that follow, blue elements are those on which we had empirical data. The core of the model was a relationship between a student's motivation to continue and his or her decision to enroll for the next semester. Building on this core, if a student enrolls, he or she chooses a course load, takes courses, and ends the semester with a performance record. When the semester ends, the student's performance affects his or her motivation to enroll for the next semester. Performance also affects how close the student is to graduating. If the student has accumulated enough credits, he or she leaves the school as a graduate. If the student does not have enough credits, performance affects his or her motivation to enroll for the next semester. Closeness to graduation also has an effect on social influence from friends and family, which in turn affects motivation. As the whole process unfolds, the length of a person's student career creates a fatigue effect, which in turn also affects motivation. This is the static model that we cast into executable form. Now, let's look at how using this model provides useful insight about evaluation. To do this, we'll go through 2 steps. First, we'll just run the model a few times to show you what it looks like. We won't provide any explanation. We just want you to get your mind and your eyes used to looking at it. This will take about 2.5 minutes. It's worth looking at all the combinations of parameters that we will run, but fast forward if you get bored. As you watch the model, keep in mind what the data readouts are. The census graph on the left shows the size of the student population for the random sample the model drew, the number of dropouts, and the number of graduates. The graph in the middle is a histogram of student motivation. The agent world on the right shows the status of each student in the sample for the semester the model is running. It's the kind of pattern observation that can only come from an agent-based view of the world. So, on the left, we have two graphs showing very traditional descriptive statistics. On the right, we have the distribution of each student, aka each individual agent, for each slice of time in the census graph. Now here is something else that's interesting. So far, you've been looking at how individual students move about with respect to overall graduation and dropout rates. In other words, you can watch the student population as it evolves over time. That is one of the unique contributions of thinking in terms of agents. But from a display point of view, something is still lacking. In the CyberWorld display, it's easy to see clumps of students, but not so easy to follow the progress of individual students. Fear not, we can do that too. Watch. Now that you have a sense of what the AJAC model looks like and how it behaves, it's time to compare the model with our real data and ponder the evaluation implications. As we do, it's worth keeping some principles in mind about how to use models. Don't expect precision. In general, it's best to assume that there is too much noise in real-world events and too much simplicity in models to expect agreement to too many decimal places, or really any decimal places at all. What matters is qualitative agreement between models and reality. Do the shapes and patterns match, and are the numbers about right? Does the model give a consistent pattern of results over a reasonable range of inputs, or does it change radically with small input changes? Each of these behaviors conveys a very different message. Finally, be aware of any intuitive understanding of a program that you are developing as you look at different model runs. What you should be after is rich pattern recognition and the inductive insight that brings. You should be working your way toward a deep feel for how the program works and why. We are only going to show you a few of the many runs that we have done. We chose these to illustrate how the executable model provides insight about the static model and the implications for methodology and metrics. If you want to see other runs, just call us and ask. We'll be happy to fire up the WebEx and do more demos. Keep in mind that the NetLogo interface was built to reflect our original static logic model. We are now going to show you some of the things we can learn by moving from this static model to a dynamic agent-based model. In the sequence we are about to show you, we are going to keep all the elements in the model at a relatively low level, and then to vary the central element of the model, motivation. Let's see what range of motivation reflects the actual data on graduation and dropout rates. Don't forget that we are working with variables representing 5 elements of the logic model: motivation, fatigue, social influence, class performance, and closeness to graduation. For reference, here is the actual data from the AJAC evaluation. In the executable model, all of these can vary between 0 and 1. For the runs we're going to show you, everything but motivation is set to 0.1. These are what the data look like when we set motivation to 3 levels: 0.5, 0.6, and 0.7. The graphs on the left are census graphs that show the cumulative number of graduates and dropouts over time. The pictures on the right are screenshots of the agents at one particular semester. It's only one slice in time, but the pictures are typical of student behaviors throughout the run. Freezing a single enrollment period seemed like the best way to give you a sense of how the students are distributed on a graph defined by percent done and motivation to enroll for the next semester. Consider what we are doing as playing with a thinker toy. What we just showed you is a small piece of the playing that we have done. Here are some of the things we thought about. A motivation range of 0.5 to 0.7 does a reasonable job of reflecting the actual graduation and dropout rates. Non-AJAC students, the red icons, precipitate to the bottom of the percent done measure. Also, non-AJAC students seem to have more variation in their motivation scores than do the AJAC students. Staring at these model outputs spurs some interesting questions. Are the mean motivation scores for graduates and dropouts different? Is there a difference in the mean motivation scores between AJAC and non-AJAC students? Is there variation over time for the correlation between percent done and motivation? Are there differences in correlations between percent done and motivation for AJAC and non-AJAC students? I'd like to say that I had the wisdom to think of these analyses before looking at the model, but that would be a lie. I might have come up with the questions about mean differences, maybe, maybe not. But I know that it took looking at the movements of individual students to imagine the questions about the correlations. Let's look at the data that bears on some of these questions. This graph shows motivation over time for 4 groups of students: those who entered a 4-year university with and without AJAC certification, and those who entered with and without an associate's degree. This graph compares motivation over time for students who did and did not graduate. These descriptive statistics give us 2 different views of student motivation, each showing that it decreases over time. Personally, I thought that motivation would go up because the closer to graduation, the more psyched someone would be to graduate. But the model does include the effect of fatigue, which acts directly on motivation. And other model runs show that fatigue has a strong effect on decreasing graduation rates over time. I hate to be wrong, but this is a pretty good example of how models can help to test assumptions prior to actually implementing an evaluation. Further analysis provided a fuller understanding of the effect of motivation. A statistical test confirmed that the mean motivation score for graduates is significantly higher than those for students who do not graduate. Plotting the 95% error bands for motivation at each semester shows little overlap between students who graduate and students who do not graduate. Plotting the 95% error bands for motivation at each semester shows little overlap between students who enter university with both AJAC certification and an associate's degree versus those who enter university with neither. These comparisons have added weight because the group-based descriptive statistics in the graph are augmented by our sense of the trajectory that individual students follow during their student careers. This we get from the agent world window in the simulation. The clustering of those red icons at the low end of the motivation scale is dramatic. From an evaluation point of view, this data pattern indicates that if I were to develop the evaluation from scratch, it would be a good idea to include a measure of student motivation. And were I to enter the evaluation in the middle, I would do well to hurry up and get a motivation measure in there. Also, remember that although we did not show it to you, fatigue really does have a very powerful effect on decreasing the graduation rate. And in the model, fatigue works through motivation. Don't forget that the original evaluation had no empirical data on motivation or on fatigue. We constructed them because we needed them in order to develop a plausible model of student behavior. And sure enough, the fit between the model and the real data shows that we made the right choices. And this brings us back to the premise that began our research, i.e., that going back and forth between an agent-based model and data analysis makes for evaluation that provides better guidance for policymakers and program planners. Should the evaluators have gone to the trouble of adding measures of fatigue and motivation to their evaluation? It certainly seems like a good idea based on the model. We cooked it up for the static model, ran it in an agent-based simulation, and discovered that these model elements might in fact be highly consequential. On the other hand, think of what it would take to actually implement those measures. It would be neither cheap nor easy. Adding measures of motivation and fatigue would place an added burden on AGEC personnel and on staff in the universities. It would make added demands on students. Would it have been worth it to make the jump from "it seems like a good idea" to "let's actually do it"? It would be tough to make that decision based on the static model alone. Doing this work made us more certain than ever that we are onto something that can produce more powerful guidance to policymakers and program planners. We hope we've convinced you of both the joy and the utility of working with agent-based models as a complement to traditional evaluation tools. But we also know that what we are advocating can make people a bit uncomfortable. One reason for the discomfort is simply that the material is unfamiliar. But another reason has to do with a sense of futility, because once a model is executable, there are so many possibilities that how is one to know which ones are worth looking at? The answer to this question goes back to what we said earlier about working with models. Don't expect precision. What matters is qualitative agreement between models and reality. Ask if the model shows consistent results over a range of output, or if the results change radically with small input changes. Pay attention to how your intuitive understanding of the program is evolving as you look at different model runs. Of course, working with static models will always be easier, but that is only because static models ignore the dynamic behavior that will play out when the program is actually implemented. As an example, take another look at the relationship between closeness to graduation and motivation in the AGEC model. It shows only a single straightforward connection. But the fact that the picture shows it that way does not mean that it is that way. Of course, there is some kind of mathematical relationship. It's certainly okay to ignore that dynamic relationship. After all, remember George Box's famous statement about models. All models are wrong, but some are useful. If the static model is useful, use it. After all, static models have served us well in thousands and thousands of evaluations. But we hope we have convinced you that as you use your familiar static models, it's also worth considering the added value of moving from that static model to a dynamic agent-based modeling approach. We are actively looking for research partners and for programs to work with. If you know of any, get in touch with us. Thanks.